Hey guys, this is a instructional video I should have made forever ago, but I've put off for some reason. I'm going to show you kind of how to use my favorite program called Awk. Some people think it's an awkward language, but those are people who clearly don't know how to program. So this is kind of what I cut my teeth on when I first became a programmer. There's a few things that might throw you off down the road, but in all, it's a pretty intuitive program. It does a lot of work for you, so it's a great way to kind of get started. And it's really easy and very useful for parsing files. It was originally developed by AT&T back when they were called Bell at Bell Laboratories for doing things like parsing phone books. So it kind of gives you an idea that it's really good for spreadsheets. And it's really fast. The programs are simple to write. So usually I write it when I don't need a really complicated program. And you'll see kind of its advantages as we get going here. So let's see here. So let's start us off with how do you write Awk program. So I typically use it in the command line. You can use it as like its own like language where you write actual Awk program files, but where I find the most use is using it on the command line, and I'll show you why. So a simple way to write an Awk program is in this format. You'd write Awk, and you have a single quote, and then you give it instructions in this format where you give the condition, and then when that condition's met, you give it some instructions. And then once you've done, you can do as many of those statements as you want, and they'll be executed in order. And then to exit your program, you just do a single quote again, and then you give it your input file. So the file we're going to be working with is this test.txt. So you can see that's what the file looks like. So what does Awk do that's really useful? The first thing it does is it reads the file line by line. So it's not using a lot of memory. It just grabs one line of the file at a time. So it'll grab this line here, and then it'll take that line, and by default, it splits it up on white spaces. So it'll give you a line, and then it'll split it up into columns, and then it'll execute your instructions on that line. So it doesn't know anything about the line before it, doesn't know anything about the line after it, just the current line split up into columns. So I'll give you an example. So say we want it just to print out the line. So this is the equivalent of just typing like cat. So in Awk, the columns are, when they're split up, they're assigned to variables that have a $, and then the number of the column. So this is $1, $2, $3, all the way through $10 here. And then also $0 represents the entire line. So if we just want to print each line, what we would do simply is type Awk. There's a couple different ways, but to be as best an explanation, I'll show you the most verbose way, which is to say Awk print $0 file.txt. So what this is doing is it's going to grab each line, it's going to load in the line, and the whole line is going to be assigned to the variable $0. We're just going to say print $0. And what the print statement does is it prints out stuff and adds a new line at the end, and then I'll move on to the next line. So here we go. Oop, test.txt. So here we go. So it printed the line, went to the next line, grabbed it, printed it, went to the next line, grabbed it, and printed it. So that's easy enough there. So what if we want it? So we could just use cat if we were going to do that. So that's kind of a silly example. But now let's say, what if we wanted only the first column? Then we say, okay, Awk print $1. So real quick note, you'll note I don't have any conditions before this. So that just means every line. And I'll show you where to use the conditions a little bit. But if there's no condition given, then it always evaluates true and executes whatever code's inside the curly braces here. So we'll say, okay, print $1, what you see is this prints us out only the first column. Okay, it's getting more useful. So let's say, what about we want only the fifth column? Then we say awk print $5. Oh my gosh. Apparently need to fix this little thing. All right, test.text. So here we go. Now we can see we've only printed the 1, 2, 3, 4, fifth column here. So pretty useful if you want to get specific columns out of a file. But what if we want only specific rows? Say we want only rows where we're going to say column 10 here is greater than 50. Well, so this is where a conditional statement comes in. So we say awk, and before we put in the curly braces, we say if column 10 is greater than 50. Now we could say print $0, and that would print the whole line. But a fancy feature that I didn't know about a long time in Awk is that if the condition's true and you don't give it any instructions, the default instruction is to just print the line. So to save us a couple lines of typing here, we'll just say if $10 is greater than 50. And now you can see we've only grabbed those rows where $10 was greater than 50. So you can see we ignored the first 5 rows. So that's useful. So again, we don't have to give it that print $0. In fact, if you just say print and don't give it anything to print, it'll print the whole line. So we get, oops, we get the same input here. So that's the same as previous, or that's the same as well. Just a fun thing. So Awk, another thing that Awk is really good at is math. So Bash, you're not going to find great math skills in Bash, but Awk does math like a boss. It's got all the features. Okay, so say we wanted to multiply column 1 by 10. Then we just say awk print $1 asterisk means times 10. And now we can see we get these values multiplied by 10. Or say we wanted to add column 2 and column 3 together. We can say awk print $2 plus $3. Pretty easy. And there you go. What else? You can do division. You can do all kinds of stuff. So any of your math stuff you want to do, I think if you want to do powers, it's just the caret symbol. If you want to do remainders, you can do that. For those of you who don't know what this percentage means, it just means basically take column 1, divide it by 11, and then return what the remainder is. So let's see here. We'll have it print $1 and then what the remainder is. So if you put a comma in outside of quotes, what you get is basically just the default separator, which is a space. So you get column 1 separated by a space from 1 modulo 11. So there you go. Okay, so what else? Awk has a bunch of built-in variables that are very helpful. One of them is capital NR, which means the number of records, or basically what line it's currently on. So every time it reads a line, it adds 1 to this value. So if we just say print NR, what you're going to see is it's just going to count up from 1 to 0, or I mean from 1 up. So you can see you can basically give your file line numbers this way. So we say print NR and then the file line. You can do things like only print the 3rd line this way. So if we say, if we're on line number 3, then print, otherwise don't do anything. And there we go, we've pulled out only the 3rd line. Or say we just want to skip line 1, then we say NR is greater than 1. So this will only execute and print if we're not on the first line. So there you go, we're missing line 1 there. Or say we wanted only even numbers, even numbered lines. So we do if the line number modulo 2, if you divide it by 2 and it doesn't have a remainder, meaning it's an even number, print the record number in the line, and see we get 2, 4, 6, 8, and 10 for our line numbers. So that gives us only the even ones. So that's super helpful if you only want to grab certain lines out of a file, or want to ignore, like, say, a header of a file. Next, you can is the variable nf, which tells you how many fields there are. So this splits by default on white space, which is spaces or tabs. So if we want to know how many fields there are, we can say print the number of fields. And here's another useful feature that I'll point out real quick, is that if you want to concatenate things, in other words, like combine numbers and strings and stuff like that, you just put quotes around the stuff that's not a variable. Like nf is a variable, so I want the nf with a colon between it and the line, so I just put quotes around the colon, and what you'll see here is it prints the number of fields, the colon, and then the line. So that's just how you concatenate stuff in Awk. It's super easy. And so what you can see is most of these lines have 10 fields. This one has 13 fields, and this one has 11. And it's pretty easy to see. So what if we only want lines that have greater than 10 fields? No, we just say nf greater than 10. And now you see we get just basically these bottom lines. Or if we want field or lines that only have exactly 10 fields, we do nf 2 equal signs is how you say equal. If you do 1, it's assigning a variable, which is not what you want to do here. So this is saying if the number of fields is equal to 10, print them. So now we only get those fields that have 10. Other built-in variables that you might find useful are the begin and end variable. So begin basically executes before it's even opened a line. So right at the start of the program. I don't use this one a ton, but it's useful to set variables before you even open up your first line. So it does have some useful features, and it's only run once. Like it runs it before it starts the program, and then it'll never be run again. So in this case, I say begin. Begin is my condition. So if we're at the beginning, print, I run at the start, and then we'll print every line after that. So you see I've got up there, I run at the start. So it's useful for things like printing headers. The end statement does the exact opposite. It only prints once you finish the entire program, once you've finished reading the entire file. So after it's read in the last line and executed, it's any commands you gave it, then the end statement gets evaluated. So it says end, print, I'm run at the end, print. And so what you'll see is you get the whole file printed out, and then the statement, I am run at the end. I'll give some more examples of how this is useful a little bit down here. Another important thing to know how to use are variables in Awk. It's really simple. It's just you have a variable name and you set it equal to a value. So for example, I am setting the variable myvar to the value of 10. So as long as it doesn't have quotes around it, it knows it's a variable. A variable is just any string that doesn't have quotes around it. Can't be a number, but any combination of characters that doesn't have quotes around it is a variable. So I can say, okay, my variable equals 10, so I want you to print field 10 divided by my variable. So there you go. So we can just, we'll do $10 here so you can see what that is. So you can see that's the value you get out. Variables don't have to be numbers, they can be strings. So in this case, I say awk, my name is equal to Jeff, so I put quotes around my name to say it's a string, and we'll say my age is equal to $10. So I've got two separate values here, my name, my age. And now every line I'll have it print, hello, my name is, my name variable. So this is a string concatenated to my variable name, and then another string and my age is concatenated with the my age variable. There you go. So it says, hello, my name is Jeff and my age is blah, blah, blah. So that's one way of using variables. Variables are useful if you want to keep track of things, obviously. So every time it reads in a line, you lose the information in the previous line. So $10, say, gets overridden every time it reads in a new line. So say if we want to know what the previous value of $10 is, we have to save that in a variable when we read one line. Okay, so example here, I say, if we're on the first line, then 10 is equal to field 10, and then next. So next just means don't execute any code past this, just load in the next line and get there. And then when we load in the next line, this doesn't get executed because then now NR is greater than 1. And so now we're on line 2 or higher, and we say print 10. So we want to know what our previous 10 was. We want to know what the current 10 is, and then we want to know what the current 10 minus the previous 10 is. And once we've done all our computation, then we save the current 10 value into the 10 variable. So you can pause this and process that. So what we see is, okay, we're on line 2. The previous one was 9, and now it's 19. So 19 minus 9 is 10. And now this 19 gets saved as a 10, and now we're on the next line. Now it's 19, 29, 29 minus 19 is 10. And it just keeps repeating until you get to the bottom line there. So useful if you want to compare things between lines. You can also use a variable to like sum up a column. So here in this example, we're using, I've just got the variable is the value A. So all variables start out set to 0 until you set them to something. And plus equals just means take the original value for A and add field 1 to it every time you reload a line. So it starts at 0, reads line 1, and that becomes 0, 0. Then it reads line 2 and it becomes 0, 1. So we should get something like 10 at the end. Or 450, I guess. So let's do this. So we'll say print $1, and then we'll say print sum. So we know we're at the end here. So this is again when the end statement's useful, is this is only executed once we're all the way through the file. Okay, so 10 plus 20 plus 30 plus 40 plus 50, anyways, you get it. So there you go. So that's a nice way of summing up that whole column, and at the end we print the sum. You can also get outside variables. Like say we've got some variables saved in bash. So like example, here's my home directory. So that's what that variable is in bash. And say we want to bring that into awk. There's two ways to do that. The first one is with this -v flag. And so all you do is you put -v and then you set it like any other variable. So outside var is our variable name equals our bash variable. And then that's done outside the single quotes. And then we do inside the single quotes, we'll do it on only line 3. We'll say print my home directory is, and then we concatenate our outside var. And then here's an exit command. So exit just means make the program stop executing now. And for those of you who know what it means, you can also give it a number afterwards for an exit variable so it knows if it exited right or not. But anyway, so we're just printing out once we get to line 3, my home directory is outside var. So here we go. Oops. And I do some strange things. Okay, so here it is. It said print my home directory is colon and then that variable value. So that's an easy way of bringing in variables. Another way to do it is here, I'll see here. is to just get outside of these single quotes. So basically anything inside these single quotes is like a special string that's being evaluated by the program Awk. And if you end those single quotes, so here we've got single quotes, my home directory is, and then I do single quotes again, we basically are exiting into bash for a second. We are printing out our variable. This may not actually work, we'll see. And then we're entering back in. This will totally work. There's our exit. So here we go. So there we go, it worked. So it's essentially, this would be the exact same thing as if I typed this. Like the program, to the program, this is exactly what it sees. So when you exit out, you can just bring in any variable you want that way. You could assign the variable in here like that anyways. You could say var equals $. You got to put the double quotes around this though, otherwise it'll look wrong to the program. By that I mean it won't have quotes around it, so it'll assume it's another variable name. So it'll be looking for a variable with this name, which is makes no sense. So it'd be equal to nothing. There you go. Okay, so say you've got a file that's not nice, and say you got like a comma separated values or tab separated values with spaces in there. You may need to use another space separator. So let's look at this file, test2.txt. You can see I've got one line that's nice and space separated, one that's comma separated, one that's tab separated, but it has a space thing in here. So if we say awk print $2, what we get is we get the right one for here. We don't get anything for here because this is all column 1 here and there is no column 2. And for this one, rather than getting names, we get spaced. So to set how you want it to separate your fields, you use the -F flag and then give it your separator in quotes. So this one, you'll see now it treats this all as field 1. There is no field 2 for it. Now this one is split up on commas, and this one is again all treated like field 1. So say we want to do it at tabs now. Same thing. This is all treated as one field now because space separated. This is all treated as one field, and now it gives us the correct number 2 because it's spacing or splitting it only on tabs. So that's just how you do different field separators. And then this is we're getting to the end of this early tutorial, but this is just one note. So like if you were, if you had Jay show you anything on Awk, he does this, what I consider quite silly maneuver, but it's just the way he's been taught, where he will cat something. So we'll cat our test.txt, and then we'll pipe it into awk. And then, you know, you do some like print $3. That works perfectly fine if that's all you're trying to do with a single file. But awk has a lot of features that are really great past this, and you kind of miss out on them. And I'll show you an example of this, which is using multiple input files. So say we want to work with both test and text. So say awk print $2, and then we'll do test.txt and test2.txt. Okay, so we're working with both of those files. And you'll say to me, well, Jeff, you could just do this, test.txt, test2.txt, and get the same outcomes. And yes, this is true. But say you wanted to do something where you treat these files differently, or say you wanted, we'll just do this example. So another one of the built-in variables that Awk has is file name. So we could say print file name and then end file. So if you give it multiple files, you can use the begin and end, or you can use end file, and this will execute every time it finishes a file and moves on to the next one. So we'll just give it test.text, test2.text, and here you see it prints out the file names. But if we were to do this way, so we do test.text, test2.text, pipe it in, what it's grabbing here is that's just standard input. So it doesn't know it's reading two files to it. It looks like one file. So we're missing out on some of the features that it can do. So to give you an example of one of the features you can do, so we can set our field separator. So normally you want to set it with that dash capital F flag, but you can also set it either in the program or outside the program. This is one of the newer features that Awk I didn't know about. So it'll run this test.text file, and then we'll change our field separator to a tab, and we'll do this print file name, and then we'll also have it print $2. So we can have it run through test.text and print all of its stuff, field 2, and then we can change what it considers the thing to split fields on, and then run our second file. And so you see here we get the right thing. There's our file name out. And then here we got the correct field 2 out because we set our field separator to tab. You could do the same thing, set it to comma here. And we get the second field of the comma one. So that's like one of the features you're going to miss out on. There's a lot of different ones, like so if you're working with multiple files and you want to know what your current line is in that file only, not in the whole file, you can do, let's see here, we'll do begin file, print file name, and then we'll just do print FNR. So FNR is just like NR, but it resets every time it opens a new file. So here we go. So we do test 1, we go 10 lines down, then we open our new file, test 2, and we go 4 lines. So if we were to cat this in, test.text, test2.text, you'll see we can't split up these files. So what I typically use something like that for is I'll build some sort of a table with the first file and then use the second file to look up values inside that table. And you can't do that if you're catting files in. So just be aware of that. Last thing I'm going to show you is how to print things out to a file. So we've been printing stuff out to standard out, which is just basically out to your screen. So do test.text, test2.text. So you can use bash's normal redirect. So we'll print that out to file.text, and now if we cat it, we'll see our data's there. Or you can use the Aux Internal Writing, which works exactly the same, but this is pretty useful because we'll just do this. NR modulo 2 equals 0. You just use the redirect, and then the file names need to be in quotes. And then we can say NR modulo 2 is equal to 1. And FNR out to odd. So we can do that, and you'll see it still prints this out to standard out. So if you don't redirect it to a file, it'll automatically go to standard out. But now we've got a file called evens and a file called odds there. So So there's just kind of an introduction to Awk. You're basically limited by your imagination when you do this. I'll try and make a more advanced Awk tutorial here, but this should just kind of get you started and let you see some of the features of the Awk that make it so powerful. I hope this was useful for you guys. Let me know if you have any questions. I'll also put up this little R Markdown file I have here to let you guys kind of go through this at your own speed. All right, see ya.